Right. So now there are corporate processes, right? So they cooperate each other, right? So when it comes to um, cooperating processes, so one particular important aspect of it is when it comes to managing this cooperating processes properly, right? So one classic problem in this interprocess communication is called as producer-consumer problem, right? So, so I will explain briefly what is this producer and the consumer is, right? So the producer will produce, let's say, produce data, right? Consumer will retrieve data, right? So there's a given data structure, right? So that means there should be a way to save this data, let's say an array, right? So the producer will produce the data and put it into an array. So the consumer will check whether there's data available in the array and consume it. So this has to be properly managed, right? Why? Because if there's no limit, then the producer can produce unlimited data. And also, if we do not check whether there are data available for the consumer, right? So then consumer can keep on searching for the data forever, right? So this is the classic problem we discuss in interprocess communication, producer and the consumer, right? So assume that we need process IDs, right? For new processes, we need process IDs. So the producer will generate process IDs. So rather than generating when the requirement is there, so we will maintain an array, let's say 10 elements. So producer will produce the process IDs and save it on the array. So when a new process needs to be executed, then we need to allocate a process ID. So the consumer will take the process ID from the given array and assign it to the process, right? So that is the task. So now we cannot just execute the producer to produce unlimited process IDs. So there should be a limit, right? So here we consider an array called a buffer, right? So buffer will have a bound. That means buffer will have a limit, right? Let's say buffer is, the size of the buffer is 10, right? So that means the producer can produce up to 10 elements. That's all. Consumer will check on the array. If it is not empty and if there's a requirement, it will take the first element which is available on the buffer, right? So for that, we will take a data structure, right? Like this. So we will define the buffer size as 10, right? So that means we will maintain 10 elements. Right? And then we will have two given variables in and out. So both will be initiated to 0, right? So consider this buffer as an array. Right? So now we have allocated the buffer size, right? So we will, let's say we'll make it 5. So then it would be easier to demonstrate, right? Buffer size is 5. So we have elements from 0 to 4. right? So we'll check on the solution later on, right? So I will explain why this can be only use buffer size -1 elements, right? So we will come back to that. So this is the producer, right? So the producer will check on the uh, buffer, right? Check whether the buffer is full, right? If the buffer is full, right, then it won't produce any item, right? Because the buffer is full, right? So that is what is checked in this while loop, right? And so you can see this is a empty loop, right? So I will explain this condition by using a proper example, right? So I will just explain the operation. So what it will do is it will check whether the buffer is full. So that is the condition that you check here in the while loop. If the buffer is full, it will be in the while loop, right? If not, that means at least one element is free. So we produce an item and increase the value of in, right? So taking the modulus means we will take in plus 1 and the modulus, right? Mod value, right? So that is for the producer and this is for the consumer, right? So the producer will check whether the buffer is full. If full, then nothing will be done. If not, produce an item, increase in by 1, right? So that is the standard operation. Consumer will check whether the buffer is empty. If the buffer is empty, there's nothing to be consumed, right? So it's in the loop, right? If the buffer is not empty, it will take an item out and increase out by 1, right? So those are the two operations. So I didn't explain the code, but I just explained the operation only, right? So we will take an example, right? So now, so we have a buffer with 5 elements, right? So you need to understand this very carefully, right? So we have the buffer size of 5, right? And each is considered as an item, right? So we will create a buffer of 5 elements, right? So we do it here in this code. So we have 5 elements. There are two integer variables, in and out. So in and out, right? So in is point to 0, out is also point to 0. So at the moment, buffer is empty. So we just initialize the buffer, right? So that is the first thing we need to realize. Then we will check on the consumer. So in the consumer, first we will check whether in equals out. So when in equals out, that means the buffer is empty. If the buffer is empty, then the consumer cannot do anything. Why? Because the buffer is empty, right? So the consumer will be inside the loop, right? So it will be inside the loop because there's nothing to consume. So in the meantime, the producer will start the execution. So when the producer starts the execution, what it will do is check on the condition. In plus 1 mod buffer size equals out. In is 0. 0 plus 1 is 1. Mod buffer size? Buffer size is 5. So what do you mean by 1 mod 5? Now in is 0 plus 1 is 1. Mod buffer size is 5. So 5 mod 1. So when you take the modulus, right, you take the remainder. So when you divide 1 by 5, the remainder is 1, right? So you take the remainder as 1, right? And check whether it's equal to out. Out is 0. So 1 equals 0. This is false, right? So then if this is false, exit the loop. Buffer in equals 10. Buffer in means 0. This becomes 10. Now new in will be in equals in plus 1 mod buffer size. So here we are just checking. We are not initializing a variable. So but here we are initializing, right? 0 plus 1 mod buffer size. This is 5. 1 mod 5 is 1. In becomes 1. Like this. Right? So is it clear how the code works for the producer? Any questions? Right. So let's execute the producer again. Now what is the value of in? Or what is the value of in? So can anyone answer? Right. So it should be 1, right? I think you have mistakenly put 11. Right. It's 1, right? So now we check the condition. So in plus 1 or in plus 1. Now in is 1. 1 plus 1 is 2. Mod buffer size. Buffer is 5 equals out. Out is 0. Right? So what is the condition of the while loop? True or false? False, right? Because 1 plus 1 is 2. 2 mod buffer size. 2 mod 5. The value is 2. Out is 0. 2 equals 0. False. Then what do we do? Now the in is 1, right? So buffer 1 becomes 10, right? So buffer 1 becomes 10 and new in value becomes 1 plus 1 mod buffer size. 2 mod 5, new in value is 2, right? So buffer 1 becomes 10. So this will be 10, in moves to the next element, right? So it is actually like a pointer, right? So it points to the next free element. So now actually you can get an idea about the operation. In always points to the first empty element. Out always points to the first non-empty element. Right? So what is the next step? Check again. Now in is 2, right? 2 plus 1 is 3. So what is the condition of the while loop? So again, false. Why? Because now the value of in is 2. 2 plus 1 is 3. 3 mod 5 is 3. Out is 0. 3 equals 0, false. Now buffer 2 becomes 10, right? In becomes 2 plus 1 mod 5 is 3. So in points to the next empty cell and buffer 2 becomes 10. Right. So in the next iteration of the producer, what are the values of in and the array? Right? What are the values for the buffer and the in? Right. So Yes. So there are few responses. I think some of them are correct. So the while loop is false, the condition is false, right? Because the current in value is 3. 3 plus 1 is 4. 4 mod 5, remainder is 4. 4 not equal to out, right? So that means 4 not equal to 0, so it is false. So buffer 3 becomes 10, right? And in value becomes 4, right? So like this, in becomes 4, right? And buffer 3 will be initiated to 10. Right, now when you run the producer again, what is the next value for buffer and IA? So what is the condition of the while loop? Right, so while loop becomes true, right? So that means what? So now in is 4. Yes, right? So in will be 4. 4 plus 1 is 5. Buffer size is 5. 5 mod 5, value is 0, right? Because when you divide 5 by 5, remainder is 0, right? So 0 equals 0, it is true. So when it comes to that condition, now the producer is in a infinite loop, right? So it will be inside the loop. So it cannot exit. Why? Because every time in plus 1 is 5, mod 5, right? Then it is 0, 0 equals 0. True in the loop, right? So it will be in the infinite loop. So cannot exit. So can this empty cell be filled? Can this cell be filled? This time we can't, right? So this time we can't. So there's a problem, right? So producer cannot produce any more items. So this is where the producer will stop producing items. So our goal is to limit the producer, right, by producing unlimited items. So that goal is achieved, right? So this producer cannot produce more than 4 items, right? So this is inside the loop. Now let's look at the consumer. So now what is the output of the consumer? Now you know how to run the sequence of instructions, right? So tell me what happens on the consumer. Right. So here we check while in equals out. Now what is the value of in? In is 4, out is 0. Is in equals out? What is the condition? False. Right. So then this will exit the loop. Item buffer will take out a value. Right. Buffer out means 0. So we will take out that value and buffer out becomes null. Buffer 0, this becomes null. This becomes empty. Right. Because we are taking the value out and making this empty. And then out equals out plus 1 mod buffer size. Buffer size is 5, 0 plus 1 mod buffer size. So 1 mod 5 is 1, out becomes 1. Right? So that is the operation of the consumer. So what happens when you run this again? Run the consumer again. So what are the values of in and out? Yeah. So in value is 4, out is 1. So the while this condition is false, right? Because in is 4, out is 1. So we remove buffer 1 and make this null, right? And out will be out plus 1, not buffer size. So out would be 2, right? So suppose that we have the producer in the loop, right? Previously the producer is in the loop. Now what is the situation of the producer? So what is the condition? What is the output of the condition? So it is false, right? Why? Now in is 4. 4 plus 1, right, is 5, right? 5 mod 5 is 0. Out is 1. 0 equals 1. This is false. Now what happens is buffer in, right? Buffer 4, we will fill the value 10 and then increase the value of in by in plus 1. Now what is the value of new in? Yeah, value is 0, right? Because 4 plus 1 is 5. Buffer size is 5. 5 mod 5. When you divide 5 by 5 and the remainder is 0, in becomes 0. So we have free space. Now fourth element will be filled. Now in becomes 0. Right? So now we will come back to the consumer. Consumer can consume items one at a time, right? So here we can do the consume, we can run the consumer again, right? So in not equal to out because in is 0, out is 1. So we remove the buffer 1 and make buffer 1 as null and we increase out by 1. Right? And so like that, we can keep on removing these values until everything is removed. Now we are back to the initial state. All the items are consumed, right? And there's nothing else to be consumed. So now again, in equals out, right? In equals out. So consumer cannot consume anything. This will be in a infinite loop.